Let's talk about the measures of association between two variables. And we'll start by discussing the covariance, which tells us how two variables are related. Now, how do we compute the covariance? Let's say we have access to population data, right? Then we calculate the population covariance, which is denoted by sigma xy. So sigma xy is a covariance between two variables x and y. So sigma xy is equal to the summation of xi minus mu x times yi minus mu y for I going from 1 to big N divided by big N. Okay, where N is again the population size, right? And we have mu x being the population mean for the variable x, and then mu y being the population mean for the variable y. Now again, oftentimes we don't have access to population data, so we have to deal with samples, right? And the sample covariance, which is denoted by Sxy, is equal to the summation of xi minus x bar times yi minus y bar for I going from 1 to small n divided by small n minus 1, where small n is the sample size, x bar is the sample mean of x, and then y bar is the sample mean of the variable y, right? Okay. Now if you remember when we talked about the summation notation, one of the results was the summation of xi minus a times yi minus b for I going from 1 to n is equal to x1 minus a times y1 minus b plus x2 minus a times y2 minus b plus all the way to xn minus a times yn minus b, right, where a and b are constant. The same idea applies here when we want to expand the numerator, right? So the covariance Sxy is going to be equal to x1 minus x bar times y1 minus y bar plus x2 minus x bar times y2 minus y bar plus all the way to xn minus x bar times yn minus y bar. And then you divide that numerator, divide that sum by n minus 1. So let's look at a quick example. Suppose we have a data set with 4 observations of x and y. Right, 4 observations. So we have the pairs x1, y1 as the first observation, x2, y2 as the second observation, x3, y3 as the third observation, and then x4, y4 as the fourth observation. Okay. Then we calculate the sample covariance. So the sample covariance as xy is equal to x1 minus x bar times y1 minus y bar plus x2 minus x bar times y2 minus y bar plus x3 minus x bar times y3 minus y bar plus x4 minus x bar times y4 minus y bar. Right? And then we divide this by we divide this by n minus 1, which is 4 minus 1. So that's the covariance. Now, as we will see in an example later on, a disadvantage of the covariance is that it depends on the unit of measurement. So covariance is dependent on unit of measurement, and because of the fact that it is dependent on the unit of measurement, we cannot compare the strengths of the association between different pairs of variables. So we can't compare strengths of the association among different pairs of variables.